Good evening, everybody. Yeah, it's quite interesting because, yes, I have talked quite a lot about renewables as a whole, but that's the first time I think I've been on this stage, so I'm just trying to get used to the lights. So I apologise for the glare you'll be getting off the top of my head. So I didn't go into makeup earlier, so that was a mistake. Um, the reason I want to talk to you tonight about the barriers is it's been something, well, it's actually the reason I'm in Orkney. We came up on a diving holiday in 1994, and the way it works is you have a deep dive in the morning, you waste time around lunchtime, get rid of your degas, basically, and then go for a second dive in the afternoon. And on one occasion, Mark Webster, who was running Sunrise out of Stromness, took us after our first dive to Lambholm, put us up against the pier, and people then went off to have a look at the Italian chapel for a couple of hours. And after that, you're still waiting around, and a friend and myself were standing on the end of Barrier 2, just throwing stones at the shipwrecks, just chatting. And I could hear running water. And at the time I was working at the Environment Agency, south, so the equivalent of Scapa, and we've got a passionate urge to stop wasting water. And so I went looking for this water leak that I could hear. And in fact, I discovered that it wasn't a water leak, it was the fact that the water was higher on one side of the barriers than it was on the other. And that really triggered a whole lot of activity, which eventually led me to taking on the job at EMEC. So the barriers are directly responsible for this, and most particularly, the thing that is really responsible is this book by Alistair and Anne Cormack, The Bolsters, Block Chips and Barriers. I think it had only been produced around 91, 92, so it was quite new when I first came across it. And it's a simply brilliant piece of work. But it's based upon the work by the resident engineer, the photographs that were taken by the second engineer on the site, Gordon Nicol. And without those photographs, I don't think we'd have this story. So you can read all the dry text, and believe me, there's a lot of it here, but the photographs really bring it all to life. So my thanks specifically to Alistair and Anne and Gordon Nicol, but also the usual suspects in Orkney. So the Linus Museum, who sold the damn thing to me in the first place, Orkney Archive, who are unfailingly helpful in various things, and the Institution of Civil Engineers, and also Balfour Beatty, who I had the pleasure of meeting, John Andrew, who was one of the lead engineers at Balfour Beatty, and he let me rummage around in the boxes under his desk, and there were some other photographs in there as well, which was quite something. So this evening, I want to talk to you about the barriers based on the last 77 years of their lives. In fact, we'll go back beyond that and look forward to their centenary, because I think there's some interesting things that we could do. I'd like to talk to you about those towards the end. But I'm bringing a particular perspective tonight because we all come with baggage and background. My background is I'm a civil engineer. I was a diver, but I'm recovering now, so if any ex-divers will know the feeling. I'm a passionate environmentalist. I'm really determined to make sure we have a sustainable future on this planet. I'm doing everything I possibly can to make that work. And now, having been involved in EMEC and indeed before, I'm really involved in the whole renewables space. And I stress that I'm speaking tonight very much not as the Managing Director of EMEC, just an experienced renewables professional. But I'm very much an Orkney resident. We've been up here 18 years it'll be in August this year, and I'm passionate about making things work for Orkney as a whole. But as a civil engineer, I got my fellowship the other year, and that was a great privilege, because civil engineering is really about trying to harness the forces of nature. It actually says for the benefit of man, but I think they've broadened it now into a more environmentally aware perspective. But it is very much about taking what you find and finding ways to modify or work with it. And I have to say, the civil engineering work that was done in building the barriers is simply breathtaking. I find it remarkable what they achieved with bloody-minded determination and just got on with it. So I hope to bring some of that to you tonight, and hope put some of that enthusiasm into you. So what do we know about the barriers? Well, the barriers, we look at them in 2023. This is how it looks to a mariner. This is an extracted Admiralty chart. And the main thing is, it's actually on the joint of two charts, which is why there's a rough edge on the left-hand side. It's the connection of two charts. So effectively, if one is sailing on the right-hand side, on the eastern side, you can come into Home Sound, But there's a wall, and in fact, I know the people online won't be able to see the red dot, but the point is that the barriers form basically an edge, and here there is nothing. There's no detail on this chart on this side, because it's of no use to you at all if you're in a vessel on the other side. It is land as far as you're concerned. And the same thing applies for the other chart looking the other way. But it wasn't always this way. And in fact, that's the way it looks to a mariner, but this is the way it looks to us as drivers and normal users of the area. It's very much a road-based system that happens to jump between a couple of islands. Now, that's the first time it's been like that since prehistory. It is only the work done by the engineers and everybody in the 40s that changed that. And so if we look back to what happened back in the day, go back to 1909, which is when the last Admiralty survey was done. I think it was 1909. I couldn't find my chart when I was looking for it. But in 1909, this is a very different picture, because you can see, although I have drawn a black line between Lambholm and Glimsholm, there shouldn't be a black line there, but the area of water at the top, if we zoom in a little bit, we can see that there are a lot of these marks, and the marks are contiguous. They go either side. This was an area of passage. And in fact, down the bottom of this, there is a section which does actually say, directly above me here, it says a channel. There is a boat channel through this side around the back of the homes, which simply you can't do now because it's all full of scrap iron. So this was the last survey that was done before anybody started to put anything in the way. And obviously the first thing that happened was during the start of the First War, it was decided to seal up the entrances to Scapa Flow. And so the barriers and the block ships were installed. What's not generally known is that there was actually a proposal to build the barriers at that point. Halcrow, from the head of Halcrow Engineering, as it now is, a very esteemed engineer of his time, basically said, don't do it. The ships will be fine, you don't need the barriers, don't bother. And so there was a proposal for the barriers in 1914, which was actually scuppered in 1915. So the ships were sunk. But they didn't stay necessarily where they were. There were a number of vessels sunk, and there's an excellent report by Orca and Sula Diving, which I'd urge anybody who's really interested in to have a look at, because this is just one extract of that report, which shows the block ships as were sunk in the First World War, and one particular vessel, the Numidian, I think is how you pronounce it, showing in two different locations because it was moved after the war. Because there was actually quite a bit of pressure for clearance of the wrecks after the war, because it was keeping it was reducing access to the fishing grounds from Ham and also Bury to get out to the fishing grounds out to the east. And so there was pressure to actually remove or clear ground, and so some of the ships were shifted, and in particularly that one was actually moved and is now further out east. And the other thing was, obviously, Metal Industries had a good pick at stuff as well back in the day, so several of the ships were actually cut down for scrap, and in fact some of the vessels were then taken after the war as well. But there was quite a push to actually have a bit of a clearing up. So we're lucky they survived past or even to the start of the Second War. Then, of course, we all know what happened on the 14th of October 1939, when war having been declared on the 3rd of September. On the 14th of October, Royal Oak was torpedoed. And with it, the loss of the 800, it's either 33 or 35, somebody in this audience will know the number, it depends which source 35, thank you Len, I knew. The 835 men who were lost, and about half that number actually survived. And that was a major, major loss. That was 41 days into the war. 41 days in. And that was, I think, it was the loss of our first capital ship. And so it was a real shock to the British Admiralty to have one of our vessels taken like that. So, not unsurprisingly, there was a lot of hoo-ha, and people wanted to know what had happened. And we all know it was Gunter Preen and the U-47 who had managed to, a remarkable feat of seamanship, get into the flow. I understand he was actually a yachtsman who actually sailed around the area between the wars. But he and his crew sneaked in on a moonless night, got into the flow, that's the track that we believe they took for firing a couple of salvos of torpedoes, and then made their way back out again. What I hadn't realised until quite recently, actually, they took a different path out, so they didn't go between the same block ships on the way back out. However, that was a remarkable piece of seamanship, which was simply appalling, obviously, for the British Navy. And immediately he was effectively awarded the Iron Cross and feted in all sorts of ways. It was only the boat was only a year old. It was only on its second patrol when it came into Scapa Flow. He only made another, I think, 8 patrols. He was actually lost on the 10th with all hands about 18 months later. In all, I think they sank around 31 different vessels. So a pretty successful U-boat captain. But he was then subsequently lost with all hands in the North Atlantic, say 18 months later. But the effect of this was that Churchill came up and quite simply said, these must be closed. And his visit would have seen the torrent of water, this is actually during construction, but would have seen the torrent of water going through, and he apparently spoke to Sir Arthur Whitaker, who was the civil engineer-in-chief at the Admiralty, and said, these must be closed. And allegedly he said, yes, but it'll cost a bit. And indeed it did. It cost a lot of money. But nonetheless, it was decided it had to happen. And there's a fascinating memo, which unfortunately I've been tied up this week, and I want to get back to the archive to get hold of a copy of the memo, because it's a marvellous memo, because basically it goes along the lines of, look, we need to do something. Yes, we do. Sort of, Balfours, they're good chaps. They're doing some stuff up in Orkney, or in the Orkneys. Get them to do it. And that was it. No procurement process, no sort of extensive environmental impact assessment, no sort of public inquiries. Get on with it. And that was it. And off they went. And interestingly, the way I wrote this, I know this was wrong, because there was a lot of research done about how to do it, and then they mobilised to go to site. No, they didn't. It was the other way around. They mobilised to go to site, and in doing so, they then started off the research work at Manchester University. And that work was really done in the Whitworth Engineering Laboratory, where they worked on the information they had. And at the time, basically what they had were soundings that went across the lines where they could potentially build the causeways. And that was kind of it. And then those black and white charts at the start showing a few marks where it does 8 knots here, 12 knots there, and one or two points of data on a graph, and they had to come up with an awful lot of information. So basically, in summer 1940, they started doing some scale model tests in their labs, and they built these hydraulic models. And if those of you don't know how hydraulic models work, they are scaled in different dimensions, horizontally to vertically, due to the scaling errors that come in when you push a fluid at a scale through a model. So they're taller than they are wider. They're very distended. But basically, they built a 1250 scale model of the 2 areas which are shown by the boxes on the diagram on the right-hand side. So basically, barrier 4 was treated in one way, and all the other 3 barriers were treated together in one piece. And they did a whole lot of work to look at how they were going to make this work, and they basically tested different block design, different ways of sealing the entrances up, different ways of trying to close the site up. And they actually looked at a couple of things, one of which was looking at additional ships. This was the block ships as they were at the start of the Second War. The 2 diagrams are basically the same, but they looked at whether they could push causeways out from the land. And you notice that the causeways go to a different distance below the meridian, the ship on the angle. So they looked at what would happen at the velocity. So they in this scale model built little barriers, and then with pitot tubes sort of tested the water pressures at various places and see what was going on. And they worked their way through that. And they also looked at the possibility of putting in new block ships. What would work? How would they best block this up? And came to the conclusion that in fact the causeways were the best way of dealing with it, but they realised that end tipping a causeway out from the shore was simply not going to work. So at some point the velocities are so strong it just strips the end off, and you never manage to build beyond a certain point. So they really had to go to a different process. So basically they decided to end tip from the land to a point to, I think it was 6 feet below lowest astronomical tide, and then from then on they had to come up with a different system. And that system principally involved the construction that we know about using these aerial ropeways. And going back to the point about what the the laboratory did, they tested things like how big a block do you need to obstruct this, and they came up to the conclusion that they'd use 5-ton blocks. They don't seem to have had a geologist on the team, because at some point they said, well, we use some 5-ton stone blocks from Orkney. Anybody seen a 5-ton block in Orkney? Maybe at Yesnaby, some of the millstones, if you're lucky, but it's not the way the geology works here. It's a very thinly bedded mud, silts and sandstone series, and so there wasn't the rock of the dimensions that they were expecting they were going to have to use. So they had to come up with this cunning plan. And this is the point about mobilise and then research, and it was a very iterative process, how they managed to make it work. So they came up with a process which did involve dropping rock in the sea, but binding it into what they call bolsters, so effectively large metal nets which took 5 tons of rock at a go. So what I want to do is talk to you a little bit about the construction, because obviously this is when it actually, this is when it was actually built, but I want to take you through a little bit about how this was done, because once again, I'm absolutely amazed about what they achieved. The gaps, by the way, are around, each of the barriers is about 2,000 feet, so it's about 600 metres shore to shore, with the exception of barrier 3, which is that bit shorter. And the depths of water, barrier 1 was 46 feet, so 15 metres or so between lowest astronomical tide and seabed. Barrier 2 is 39 feet, 26 on 3 and 29 on 4. So they were dropping reasonable heights. So I was trying to do some quick maths. We are looking at barrier 1 being the sort of height of this building. That's the sort of scale. So you're dropping rubble in the sea to build something this high. So quite an interesting exercise, to say the least. So construction, how do they actually make it work? Well, we've got these ropeways in here, and these things are actually called Blondin cableways, named after the famous tightrope walker who used to wander around between various high points. The cableways were had been used before, so this was them actually when they were used on the Tigris at Kut in Iraq. And they were used until 1939, and Balfour's had done the job, so they knew how to make all this stuff work. So they brought 4 of them. Some books say 4, some books say 3. Brought them back to the UK and modified them. And then they also had another one which had been used at building a bridge at Dorney. The 3 that came back from Iraq were actually electrically powered. The one at Dorney was steam powered, and basically it's a rock cable car. That's the easy way to say it. You put stuff rock, or take it at some point, and then you drop it, and off it goes. But however, the challenges of doing that are non-trivial, and the way the whole system is actually put together. I want to take you through how that works. I'm sure you've probably done it, but if on the off chance somebody hasn't been to the Fossil Centre, I really do urge you to go to the Fossil Centre and look at the exhibit they've got there. Really good, great on a wet day and getting kids to play with building barriers. So the exhibition they had there was great. I hope it's still there now. So how do you actually make it work? So first of all, you've got a bit of a challenge. You have an island. That's it. You haven't got a pier, you've got nothing. So the first people row up, get wet feet, and wade ashore with boots now full of sand and gravel, and have to build a pier. So you have to build a pier. So you've got to build a pier on Lambholm, you've got to build a pier on Glimsholm, because there are no piers. And the construction that actually went on, I think is quite remarkable, because by the time they finished all this lot, they had 2,000 people employed. They built 4 camps. That's everything, cookhouse, water, sewage, the whole bit. 3 piers and headquarters. Opened up 7 quarries and expanded Moss Quarry back home. They'd laid railway tracks, 40 locomotives, some of which steam, some of which were diesel, and hundreds of carriages. 5 different block works, making the concrete blocks they had to put up. 4 cableways, as we're going to look at in a minute. The lowest of which is 135 feet high, and the other 3 or 4 are 175 feet high. They had 3 diesel power stations they had to build, roads on 2 different islands, a fleet of vessels, and by the way, they had no divers. This was a non-trivial exercise we were undertaking in the war. And at the end of it, they reckoned that Balfour's fees were about £2.5 million, and that was the sort of cost of putting the whole thing up. Oh, by the way, he got free labour. I forgot about that bit. So there was, it was a huge exercise. So I want to talk you through some of the stuff that actually went on. But so if you got, first of all, if you want to build a cableway, where do you start? Foundations, good start. Big block of concrete, upon which you then erect the 60 metre or so high pylon, and there are a pair of these on each of these blondins. To stop the thing falling over, it's obviously guide as you put the whole thing up, and that must be fun in the Orkney weather. And then you have a back anchor, which is going to take the weight of the rock as you send it out. And you basically put a line from there at the top, and then a line is then rowed across to the other island, and then hauled into the sky on the other version of this that's on the other island, and you tie the whole thing up and get the tensions up. And it's one of those things about taking a thin line across and then pulls a thicker line, and a thicker line, enough you eventually go. And the dimension, unfortunately I've forgotten to bring the dimension of the cables with me, but it was a significant piece of work. And then you need to have an engine house, and the engine house has got a cable which will run up to the top, and the cable then runs out to the trolley unit, which then hangs on the cable. And so you can imagine it's a system which allows you to load that box on the ground, lift it into the air, trundle it out to a distance, and then when you're ready, you push the button and drop it into the sea. Great. And then repeat 66,579 times, because that's how many blocks they dropped. 66,000 blocks. Okay. Now, I don't know about you, but that's quite an interesting motivational challenge for somebody to say, can you do that again? Another 66,000 times, please. There's a lot, there's a hell of a thing. And there are challenges there between, you can imagine you've got this cableway structure that's there, from which you've got a 5-ton block, which you then release. And what does the cableway do? Up into the air. So the whole process by which this thing was banging and twanging and going off was a sight to be seen, apparently. And a lot of the work that going back to the hydraulics lab had done, they'd worked out how far these blocks were going to go. If you drop them in a tide moving at 8 knots, where are they going to be? And so there was a lot of work about systems of trying to find ways to get this lot to land where you wanted them, both horizontally but also laterally, because you've got 2,000 feet between here and the pylons at the other side, and you've got to make sure you drop in these in a sensible manner. I mentioned as well, you drop in the concrete blocks. I just don't underestimate the scale of what that looks like. This is a ham. That's 12 blocks high, that thing. Now, that's a lot of concrete, and you've got to get cement from somewhere. That's got to be brought in, the aggregate quarrying, the scale of the work that went on around this that was just mind-numbing grunt job with a shovel, Huge amount of work. And I think there were 5 blockworks actually built. Furthest one away was actually Tankernes. They had a one-way system around the East Mainland to actually bring the trucks in with these loads in to bring them in and then go back and pick up the other blocks. So the other thing is that I said you could drop in these blocks a distance 2,000 feet out, but you also got to put them side by side because you need some shape. And this is a view down one of the barriers to when they'd actually raised it to the surface, and I'll talk about that in a second. And the 2 masts you can see in the background, they actually were able to use them to drop blocks in this sort of cross-sectional configuration by being able to sway the masts one way or the other, so they could luff them, as it was very naval approach, or yaw them in my words. They could move them one side to the other by about 20 feet or so. So you've got a space where you can drop 20 feet one side, you've got a gap between the masts, and you've got the other one, and you go 20 feet the other way. So you can go, it's probably 60, 70 feet across on the base. And that was the plan. And effectively what they did, and once again, my apologies to the people who are going to be viewing this later, have to do it with the red dot, but they basically dropped piles of these bags of rubble here, and then filled up with rubble in between. They then dropped other blocks on the bolsters on the side, and then filled in a bit here, and then they put more bolsters on the side. So some bits were done with these bags of rubble, 5-ton bags of rubble. And some of them were done where they just chuck rubble from a skip. And obviously the point is, once you've got two walls up on the side, you can fill this with rubble and it won't wash away. But there was very much a different parts of the barriers were done in a different way to actually bring what they call a knife edge right to the surface. Because you can imagine doing this for a period of time. You must get the stage going, is this actually working? Because I can't see anything. I've been at this months. So they did go through a process where they drop repeatedly in one particular area to simply get a pimple to come above the water. And then they would think, okay, let's see where we're going now. And they would then spread that out, or there were knife edges of these blocks, and they'd fill between them. The point is, if you build a wall like that, that's not very stable. You tend to build a course and another course and another course and another. You don't just put a pile here and a pile there and chuck some stuff in the middle and be all right. So these were very unstable structures, and so this comes back to bite us a little bit later on. So yeah, so they overall, I said the 66,000 concrete blocks on the outside, but they actually also put in, I've got the numbers here, 492 cubic, 492,000 cubic yards of stone was put in, and 330,000 tons of concrete was actually put in all this lot. So over time, they dropped these blocks in, and they started to build these structures up, and they came up at different rates and different sites, because some of them were deeper, some of them were longer. And over time, we then got to the stage of this whole knife edge approach being visible. And you can see right at the top, there's like a U-shaped piece, and that's the causeway that's been pushed from the end, pushed out from the land. And in the middle is these blocks are filling the bits in between. And eventually, this is barrier 2. You can see they've got to the surface and it's continuous, and the water just running through it, and eventually broadening the structure out and getting some more substance to it, and finally getting a road on top of it. And the road was in 1944. So you can see the process that they went through. Once they'd actually got the structure of the blocks, or the barriers in, concrete blocks were put on the outside, and then bigger blocks, 10-ton blocks, were actually put in the surf zone on either side, because that's where the wave impact really will hammer the barriers and take the blocks out. So quite a remarkable piece of work. And over time, the thing that gets me at the speed with which this happened, they started in March 1940. 42, they got about 8% of the rock actually placed. Peak labour around about 2,000 people was 43. December 43, they were up to 90% of it filled, and by 44 it was 100% filled, and all the blocks were on the outside, and it was finally opened in May, as we know, 1945. And that's Gordon Nickel being presented there at the ribbon cutting ceremony. And we all know the pieces about the fact that they were renamed the Churchill causeways during the course of the war to actually avoid any intrusion by the Red Cross, because we shouldn't be using prisoners of war on war works. So by redesignating them causeways rather than barriers, that got around that. Good tip there politically. If you've got a problem, redefine the problem. And although interestingly the name of the barriers has then sort of come back afterwards. But, you sort of think, that will be it. Well done, everybody. Fantastic. Job done. Everybody goes home. We all shake hands. We're all friends now. Go off in our different directions. But in fact, the barriers have now had there's another phase that's really gone on, because the barriers themselves have not stayed still. Because as I mentioned, they were just thrown together. I'm not in any sense being patronising about the people who did it, but the stuff was just dropped and put together. And it was not a solid structure as we'd see with some sort of defensive work. So after the war, there were a series of stages, and I want to talk about some of these things that have gone on, because at the opening you think, great, all done, fantastic, we're all great. The barriers sort of slightly disappeared into the background. People just took them for granted. People like myself who've moved here, seen them, they're just there. You never really thought much about them. And we don't realise the changes that actually went on. because there was a major reconstruction in between 47 and 50, I think, when they had to take them really to bits and do a lot of work. And the maintenance has been an ongoing thing. And our thanks very much to Orkney Council and the engineers and the teams who've worked on them over the years, keeping them in place, because they really have become a fundamental part of how Orkney works. And then more recently, we've had the issues with overtopping, the usual, well, thank goodness for the occasional bulletin from Radio Orkney about the barriers are shut today and, pick your moment. And then some studies have been done about the barriers, and I'll talk about those a little bit as well. But one piece I did want to really stress was something that I hadn't really appreciated, was the social impact of what the barriers actually achieved, because there has been something of a general decline in population on the Isles, and looking at the electoral roll effectively across the islands over the years, and I can barely read this one actually, so they go back to 1781 on the left hand side, and each of the lines is a different island group, and the main point is that there's only one set of islands, which is the blue, paley blue one, which really kinks upwards, and that's South Ronaldsay and Bury. And if you look at the actual population from each of the different parishes, North Ronaldsay, what's that one? Can't read it. Walsall Flotter, Stronsey, Rousey and Wyre, Edy, and Shappensea, and then you put South Ronaldsay and Bury on. That's the only one that's actually got a rising trend, and that, I would argue, is entirely due to the barriers. So, they've had an impact beyond their intention. They were originally designed to stop submarines getting in, and then we realised that we'd use them to stop getting torpedo boats in, but basically it was a security structure. They then became part of the road infrastructure, which has allowed people to colonise effectively or stop depopulating areas that otherwise would be too much of a challenge. So they've seen a change in their role, and they've now got water mains across them and fibre and goodness knows what else, is they are very much a conduit for modern life. But it's interesting to me how, frankly, the concerns about the barriers have really changed over time, because at the start it was all about, once you build the things, settlement and erosion. Are these things going to deteriorate? Are these things going to wash away? So a lot of work was done on that. And in 1947, a lot of boreholes were sunk all the way through the barriers, and they frankly scared the living daylights out of themselves when they found how rough they were and the holes that were inside. And there's a lot of flapping that went on around that if you read the reports about it. And then that led to the reconstruction in 47 through to 50, I think it was. And I'll talk more about what they actually did there in just a second. Once it all got settled, that was okay. We then moved into a different phase, and it's very much about rather than just the presence of the barriers, are they still there? It was about how do we improve them? How do we raise the carriageway above the water level? How do we keep people on the vehicle, on the barriers? So I never thought of them not having crash barriers, but I think about them now and I go slightly sweaty thinking about driving across that. And by the way, they were only 10 feet wide at the start, they were widened out to 16 feet later. And then obviously the wave wall was installed, and that was between when I came out diving and when we moved up here. And then the concerns at the moment are really about the road surfacing and the ride after there was that accident with the motorcyclist the other year. So really it's become a road safety issue rather than doubting whether the barriers would be there, which was really the change that went on over time. And so really what's happened just a bit about the reconstruction. So this was done, and it was really about concerns over settlement. There had been routine survey stations where they could have manholes in the surface, and you could go down and check various bits and pieces, and they were surveyed onto on a regular basis to find the movement of the barriers. And they noticed the barriers were settling during the summer more than the winter, which is quite strange, and the barriers centre lines generally moved westward. Fractionally, so there's a sort of settlement sagging thing that was going on. So they did a major piece of reconstruction. Now, this is not the reconstruction, I can't find a photograph of it, but this shows the structure that was there in 1944 that they basically took to bits and rebuilt. Because what they did was they took the blocks off the outside of the barriers, took them away, and took the barriers pretty much down to sea level, and then solidified things by putting a lot of grout, so cement and marine asphalt and various things to tie the whole structure together, and then they rebuilt it from basically the water level up with these 10-ton blocks, which effectively like railway sleepers all the way down through the barrier, and then the road structure on the outside and blocks to cloak it. So it's quite a complicated jigsaw that's there. So it's not an easy job to sort of to untangle this thing. So it's quite a structure now. It's actually more built. And they removed and rebuilt this lot, took a lot of the substandard stone away, and used it for aggregates. And then over time, they recloaked the barrier with more blocks, and that's really what the council's been doing for a lot of years since. You know, I was amazed that we're still making blocks for the barriers and putting that on occasions and cladding the structure and just putting odd ones on, because sometimes they will tumble off and roll down the side, so they need to be kept in place at the top. They also poured a lot of, say, marine asphalt into the whole thing, and that's a system where you heat asphalt up to about nearly 400 Fahrenheit with sand and cement in it, and then pour it into the barrier, and it's so hot it'll go through water and still stay hot and then stick to things and eventually cools. And there's quite a lot of that in the upper sections of the barrier to prevent the erosion. Another thing that's also gone on, I think we also don't appreciate, is the whole issue of sand accretion, the amount of sand that has actually materialised. So this is an extract of the chart from 1909, which you may recognise. And after I came out diving, I got interested in the barriers, and I tried to make a scheme work, which didn't quite happen. But we did some work where we digitised the charts from 1909, and also then compared them with the 2000 hydrographic survey. And the interesting piece is this blue area, which is tied up against the barrier, which basically indicates shallow water. And of course, it wasn't shallow water back then; it's now shallow water up against the barrier. And if you digitise the old one and digitise the new one, and then subtract one from the other, you find that over 9 million cubic metres of sand has appeared on Orkney's coast. And that was when we did this work back in 2004. And there's been a hell of a lot more than that now. So we're probably into the 12 to 15 million cubic metres of sand have accumulated on Orkney. And that's the true, we should use the word on Orkney, because it's on the island of Orkney, so I'll take that. It's actually accumulated, piled up in the various bays, and obviously the main place we've seen that is Barrier 4, but also Glimpsholm Beach, where there's, you can see the sand has accumulated there. I did some work with EMEX some years ago. We put some more cables in, and we had a cable layer doing that at Sovereign. Some of you may have, I think, came around and had a look around the ship back in the day. And we were weathered in on one night in Scapa Flow, couldn't get out. And we were looking at a particular area of site where we wanted to possibly put the scale test site, which is over near Bury. So we actually put a remote operated vehicle over the side and did some work on the seabed, and with a pressure hose blew a hole in the seabed to find out what was there, just washed it out. And there's an interesting sand horizon and a shell horizon that's there, which is covered up probably by the sand that is then washed in as a result of the barriers being in place. But that sand accretion is really quite remarkable that's gone on, and I think if I can just illustrate that with Barrier 4, which you probably already know, and a good marker is the Collingdock, which was a Great Lakes steamer between the wars, which was sunk, and this was it in, I think, the 80s or so. This is a photograph from Charles Tate, which is found on eBay, a postcard, and this is Google Earth now, and I think you'll find the Collingdock is sort of basically the bridge of it, which is very characteristic. This shape is actually still sticking out of the sand and is around here somewhere. And so you can see the amount of sand that's actually accreted around Barrier 4. And basically what's happening is that will keep happening until Barrier 4, that bay, fills up, and the rest of the sand will then spill around the corner, and is already spilling into the area in front of the other barriers. But at some point there will be a surge of sand which will come in there when this coastline starts refusing to receive any more because it's full. And so we can expect some significant change that's going to go on. Which leads me on to one of the problems that we've got over the barriers at the moment, which is that of overtopping. And so we're all used to this sort of thing, and the signs going up, and the pictures of the wave wall getting a battering. for the waters coming in from the east, but what we also don't seem to talk about quite so much is this is it from the west. And indeed, in the reports of the building of the barriers, they talk about the storms being more severe from the west, really not coming across the flow, having more disruption. And so the issue with the wave wall is it's on the wrong side of the barriers for this sort of thing. So there has been work done to look at different ways of dealing with this, but this is where I think I want to talk to you about what I see where the barriers are going. So for the next 23 years to its centenary. So I generally believe that there is a huge opportunity that we've got with the barriers, because we have seen the barriers change over time, and that when we originally had them, they were very much there just as a defence. They then really became a road, and that was our principal use of them, and as a conduit for cables and pipes and bits and pieces. But at the moment, they are just a cost to us. You know, we end up having to spend maintenance on this all the time. And I believe there's a way to change the barriers round in certain ways to make them actually a revenue earner. And in doing so, we can actually create a sustainable energy source. And I believe we can deal with a better access. But the point is, the question I'm going to pose to you tonight is, are we actually willing to look at another change to the use of the barriers? Because the big idea that I want to pitch to you is that we should really replace barriers 1 and 2 with a bridge of some description. Now, just barriers 1 and 2, leave 3 and 4 out, there's no need to do that. But I believe that we can actually use the legacy of turning that structure into that, and the legacy will allow us to build something for the future, which I think we can then turn our cost into revenue. We can find a way to actually generate revenue from tidal energy by using the barriers in a particular way, or the sites in a particular way, and that could actually generate revenue for the economy of Orkney and support activities just in the same way that Hammers Hill supports things at the moment from the wind turbines. So I'm going to look at one particular aspect, first of all, wave overtopping, because that's the one that's really concerns people at the moment. And what we get at the moment are waves that build during the course of their coming into Ham Bay, and they basically slop over the top of the barriers. But the reason they do that now, and they didn't do that 50 years ago, is because the sand's built up underneath. And what we've got is a ramp. So basically the waves run up the ramp into shallower and shallower water and basically spill and slop over the top of the barrier. So if you want to deal with wave overtopping, there are a couple of ways you could do it. You could take the sand away. So you could dredge it all out, useful sand, dredge it all out, but the problem is that the sand will return because there's no tidal flow through that area. And the alternative really that I'm proposing is that what we could actually do is build basically a bridge next to the barriers. And a bridge is actually quite a simple structure, because if you build a bridge next to the barriers and then take the barrier out, there's nothing for the waves to slop up against. The waves will just pass through and spill out into the flow, and will then radiate out because they've come through a very narrow gap, and they will then spread out naturally as you see diffraction patterns happen with waves. And by doing that, you can actually deal with the wave overtopping issue. The point is the flow that you have back through the site will actually keep the sand out, and so you won't end up with this wave overtopping issue. The other thing is that bridges are quite useful because we've also got to recognise we've got some other changes coming at us. Climate change is here, everybody. When I was born in 1959, there were 317 parts per million carbon dioxide in the atmosphere. We're now at 417 parts per million. And we know we've got to deal with our carbon problem, but we also know we've got problems locked in based on the carbon emissions we've had so far. We are going to see climate change. We are already experiencing it at the moment. We're seeing wetter periods of time. The seasons are all over the place, and our storms are going to get more and more energetic. So we are going to get more storm events that are going to come along. So what are we going to do? We're going to have bigger waves, and we're also going to have a rising sea level. So this gives us an option really to do something quite different, because we can actually future-proof ourselves by doing this with the barriers. And the point is that bridges don't use very much material. They've got a very small footprint. The the airspace is cheap, and I'll explain what I mean by that in a second. And causeways use a lot of material, larger footprint, and building them higher is expensive. If we take the example of a bridge and a causeway built to the same level, if you want to raise the bridge higher and you want to raise the causeway, that's the sort of material you need to do that. And the point is that that proposal on the right-hand side is exactly the proposal that JBA came up with for the council, which is to deal with the wave overtopping issue, which I would point out will only deal with the wave overtopping issue from one side. And it doesn't deal with the climate change, the sea level rise side of things. So my point is that we are going to have to do something with these structures, because we're either going to have to accept that we can't go to Bury on a, go to South Romsey on a regular basis because the storms are going to be more frequent and are harder, or we're going to deal with something, and by the way, dealing with it could actually allow us to mitigate as well. The report, by the way, did actually mention some tidal options, but I have to say I thought they sought very, very limited input to it, and they didn't speak to tidal machine developers. And in fact, at the time it was done, the tidal machines were not fully working anyway. So I think that that information I think is severely flawed, and I generally think there's scope to do something else, because the opportunity we've got is basically, if we do build a bridge, and you notice I built it taller in that one, you can stand a crane on it, and the crane can then be used to install tidal turbines in the sea just next to the barrier. You can actually build the carriageway three carriageways rather than just two, so you can still have continuous passing traffic if that was justified. But effectively, you could put a series of turbines which you could just dangle off the water's edge, off the barrier's edge. And the reason that would work is you can do that, you don't need a vessel. You can just do it with a crane and a flatbed. You can do it no matter what the weather, you can just keep making things work, and that makes life a lot easier in my world. So a little bit, tidal energy, will it actually work? That's the question. Well, there's a question people used to ask regularly in the past, will it actually work? And the answer is yes, it will, because it's worked for a number of years. That's Elling Mill down in the Solent, which is actually in the Doomsday Book, and the foundations of it are Saxon. That's, which mill is that? I can't remember now. House Mill, which is on the River Lee in London. La Rance in France, a tidal power station built in 1966, and Annapolis Royal in Canada, which was built in the 80s. And of course, we shouldn't forget our own tidal mill. It was at Northvilles, at just where the petrol station is now. You know, you can see there the gallery for where the flow would come through, and effectively the PDC would be held up and would be allowed to come out. So we have done tidal energy here before we turned up with the new toys, because the new toys that are going on I think are really quite impressive, and I get excited about. This is the machine by Orbital, the Orkney company, Orbital Marine Power. This is the machine by Magallanes from Spain, which is up in the Fall of Walrus at the moment, and this is the machine by Nova up in Yell Sound, and I've left that photograph in showing the ferry for scale, and they have all been working, generating energy from the tides. And it's not just the generation, it's the supply chain side of things, because this is a photograph of Leask Marine handling that turbine in the bottom right hand corner, putting it over the back end of the boat using a small crane. My point is, we know we've got the tides, we know we've got the water, we know we've got the technology, we know we've got the skills to handle it, we know we're going to need the energy. So there are a bunch of reasons why this actually should work, because we know we're going to have to make some significant changes. This shows the decarbonisation of our energy system going back from 1998, which is sort of the time I got interested in the barriers, through to 2019, and I don't think anybody would have predicted the way coal has been squeezed out of the system so completely. But the way renewables is expanding as a slice, and in fact there's the slight tapering off on the total amount of energy we're using. But over time, gas is coming out of the system as well, and we're going to have to produce more and more electricity. And if you look at the work that the Committee on Climate Change did, these are all different types of use of fuels, and it goes through from surface transport, shipping, manufacturing, aviation, fuel, buildings, agriculture. And by the way, the aviation one, that's COVID that caused it a dip like that when everybody stayed at home. So the point is we've got some major changes to make in decarbonising all our other activities, and that's going to take energy to do it. And where are we going to get this energy from? The answer is going to be renewables. So we are going to need renewables, and it's not going to work if we do it all with wind. we're going to need to do it with other things as well. So personally, that's why I'm committed to making tidal energy work. So what would it look like for the barriers? So this is barrier 2. And I would argue that you could do it in this way. There are other ways of doing it, but this is a way of doing it, where effectively, you drive across Lambholm and you do that nasty left and then right and then down off the barrier. We could take that bend out and just go straight at that point. And it will allow you to plant a series of turbines off the side. You wouldn't be able to go, the turbines can be accessed from the bridge deck, but you can't go completely across the whole thing because the skerries limit the width of the useful channel. But you could build the bridge straight if you needed to, but it would be higher cost. But the big one really is barrier 1. That's the real prize, because barrier 1 is twice as deep and 4 times wider than the channel in barrier 2. And overall, you could be looking at something like 20 megawatts of electrical generation from that. Depends a bit on the technology, a whole bunch of question marks in there, but it's that sort of scale. Because if you look at what's going on, the barrier 1, just to give you some feel about this, barrier 1, if you took 3/4 of the length of the barrier out, that would be a 500-metre long gap. 500 metres is 15 metres deep, and it's travelling at 4 metres a second. So that is 30,000 tonnes of water a second would go through that gap. That's the scale of the energy which is sitting there, turned off, courtesy of our Italian colleagues at Alpha Betis a few years ago. So that's what we can turn on if we do it right. And that's the piece that I think is potentially extremely useful. So we actually know a load of stuff at the moment. We do know that there's energy out there, which we suspected before, but we've proven it in the last few years. We know we're going to need the energy. We know the technology is here and it's starting to work, and there'll be more development. So the technology is coming, so we'll have it ready. And we know who owns the sites, because it's us, because James Stockham bought them off the Navy a few years ago. Well done, James. So the barriers are now actually, the Sullen of the barriers is actually owned by Orkney Isles Council. What we don't know at the moment is exactly what's the best turbine type, what size they should be, how should we exactly configure them, and there are a bunch of things that we're working on. But we could actually do that, and we are starting to get to the point where we can derive some answers. And there's an interesting point about if we did barrier 2, we could run something of a beauty contest for turbines and say you've got your turbine and your turbine and your turbine in next to each other, and the best one will now put 40 of these under the other barrier. So we could de-risk this in a way that doesn't require the council to go out on a major limb for the technology side. So overall, I would argue that if we do something like this, we can solve the overtopping issue. We can have a nice low-risk solution, which gives us future-proofing, gives us up out of the water, and it also allows the evaluation of tidal energy really at no technology cost to the council. But it does also possibly allow us to show whether causeways in other areas could actually really become income-generating ideas. Do we wish to connect the Isles is a political question, which I'm not going to get into, because somebody dealt with that one back in 1940, thank you, Rashid. But if we did decide that we wanted to interconnect some of the other Isles, we could actually create a revenue which could support all the social aspirations that we've all got. And the other thing is that if we do sort barrier 1 out, it would deal with the grapefield erosion side of things, because the waves slop round that corner. So I believe there are some early benefits to really be had with doing this scheme, and I would strongly argue that once we can get on with this if we really wanted to, but we've got to want to, and we've got to want to at a different level to that which was shown in the JBA report a little while ago. Would there be concerns about this? Yeah, there would. Would this be a loss of historic structures? Yes, it would. I would argue that we would keep barriers 3 and 4. 4 because it's all buried in sand and it's got the flotter pipeline through it. 3 because it's quite shallow and not really much energy in it. But we also are going to have a problem because those barriers themselves are going to need to be changed later on. If we do have sea level rise, we're going to have to make them higher. I'm not sure how we're going to do that at the moment. So I would argue that deciding to do something active around barriers 1 and 2 would be a sensible way of going on. Is this going to cause disruption? Well, yeah, it is, but the thing is we can do this offline. You can build the new structure before you go and take the old one away. So you don't have to commit one to the other. And then there's a whole issue that's really important, because we are going to have more disruption. if we don't do something, we are going to have more disruption. Pentland ferries are going to struggle even more than they are at the moment, but they're getting access to there is going to be really difficult, and because there are going to be more storms, we're going to find more isolation, and in due course, the barriers themselves, as they stand at the moment, will not be sustainable. They will require work, and what are we going to do there? Thing is, are we worried about the environmental impact? Well, we could be, but to be brutally honest, we know what the environment was like before the barriers was there. And we know what the environment is like now the barriers are there. So to some extent, the environmental position we're going to settle in will be somewhere between those two, and we were happy with either end, so why would we not be happy with the position we get in the moment? So I believe the environmental impact side of things could be shown to be sufficiently benign. And as I said before, we could run a beauty competition for the technology selection. So I think we don't have to commit to one particular developer who may then be wrong or go bust. We can actually do this in a way where Orkney retains control of the assets and leases this and get the maximum benefit out of it. But the question is going to be the cost. And the cost of the bridges is something that we simply don't have the money for at the moment. So that's the challenge. It's getting to a point where we can decide that this is something we do actually want to do. So, conclusion, because Swain's has come out of his box down the back. I don't know if that's him coming down to tell me to shut up or something. There you go. But I mean, the point really is that we need to make sure we change, because we need to get. I can't remember what I was going to say with that. That made sense when I typed that earlier. I can't remember. I think the point was the barriers have become a necessity for our normal life, and we need to make sure that we're going to be ready to commit to doing something better with them in the future. We need to make sure that we make the most of the fact that there was massive determination shown in that period of appalling adversity. And we can actually have an opportunity to make the most of that. We can preserve everything purely in aspect, or we can actually use the opportunity that was given to us by the people who actually made things work in the past. And I think we have already seen that there were benefits beyond the anticipation of the people who built the barriers at the start. We've seen the social benefits that we've had. We've seen the mobility benefits, and that was never anticipated, I'm sure, by the people who were looking to simply keep submarines out. And the question I've really got at the end is should we use the sacrifice of others, to actually help preserve the future? And I think we really should. There's a huge opportunity we've got to do something with the barriers, and frankly, we can make this happen. And that's where I think I'd like to see the barriers go for their centenary. Thank you for your attention. I can only see one or two people gone to sleep, so that's not bad. I'll take that as a win. Oh, Dennis has come back. Excellent, good. Right, so thank you all very much indeed for your time. Thank you.
Thank you very much indeed for an absolutely fascinating talk, fascinating about the past and the possible future. So, does anyone have any questions?
Dennis, I see.
What do you think the cost is going to be to remove a couple of these, barrier 1 and 2? And what do you think would there be a big environmental impact when that happened?
So I think the bigger cost is the building of the bridges. And in terms of the size of them, I haven't got the numbers at the moment because there's been some big changes in civil engineering prices. But if you look at Hatston Pier, the extension that was built on Hatston Pier a few years ago, that is about half as long and twice as wide as what we need to do with Barrier 2. So you're looking at building the Hatston Pier extension again. That's the sort of scale. Now I can't remember the numbers on that at the moment, about 9.5 million, I think, from recollection. So it's not big money, it really isn't. So Barrier 1 will be a lot more. The active removal of the other barriers, we've also got another opportunity there, which is the fact that you can imagine you've got the piers, you now go and build a bridge, and we've got a barrier we want to dig away here. What you can actually do is put panels basically under the bridge, which will keep the water flow out, leave those panels in place, dig the barrier away, and you're then just doing a marine digging operation, which is is nothing. It's just marine excavation. And once you've excavated the site, you can dredge the sand out and sell the sand. And then when you're ready, you remove the panels, and the flow goes back through the site. So the point is that you can use the phasing of the fact that tides are turned off and it's a fairly benign site. You can build a structure in the benign conditions. You can maintain the benignness, if that's a word, by putting in some temporary works, complete the site, and when you're ready, turn the sea back on again. And I think it's a unique opportunity we've got with this. So I don't think the costs would be that bad. I haven't got any hard numbers, because the bottom line is I've got this other job I'm doing at the moment. And I haven't got time for this one, and one of the bits I'd really like to do is to try and spark somebody else's interest to go, hang on, we could do this, and get some people together to make this work, because it's outside my capabilities. So I gave it my best shot, and then ended up getting the job at EMEC. So I haven't got the energy to do this anymore, so we need somebody to take this on and try and run with it.
Reggie.
Yeah, I've heard you present this idea at a few science festivals and things over the years. I was just wondering, are you getting a sense that folk are warming to it? Is the Orkney Islands Council warming to it? Do you think they're going to go for it? And the second question I had was, for those who are thinking about the barriers as a monument from the past, would it be possible to preserve a section and move it to Linus?
Okay. So let's do the last one first. No, because it's a pile of rubble, to be perfectly honest. And the point is, you'll still have barriers 3 and 4. So that you wouldn't touch those. But it is just a pile of rock, to be perfectly honest. It's the scale of the endeavour that went into it. And if anything, the photographs, to me, are more evocative of the activities that went on. And if you still got the existing versions of the barriers that in 3 and 4, I think that would be fine. Are the council warming to it? No, not particularly. Not yet, anyway. But the big difference that's gone on since we first had this idea is that there are now tidal turbines that are working. So the orbital machine, which is now down at Haston, and in fact there'll be an operation fairly soon where they'll be doing some crane work at Haston, where they'll be lifting equivalent to the generating equipment. You'll see the sort of stuff that goes on. No, it's coming to Haston shortly. Where was I going? Yes, so that machine actually works. That's the point, and it turns out industrial quantities of energy from the tides, and the technology that's in that is the technology that we'd use for this. And there are now at least one other set of machines doing exactly the same thing elsewhere. So I think the confidence can build. And if I go back a stage and remember what happened with the council's involvement in wind, I recall the council was offered an opportunity to get involved in the Bury wind turbine at Northfield, but declined back in about 2002, 2003, because it was a bit of an out there investment and it wasn't right for them. But as a result of the experience of seeing that happen, when the Hammers Hill scheme was put up, they did decide to take an investment in that, and we are a 20% stakeholder in the Hammers Hill wind farm through the council. And that's now led to the next stage, which is the council now being willing to go out ahead and become a developer of wind farms because they recognise the value. So my point is, I think it's unreasonable to bounce them into something that would be too risky. But I genuinely think the risk of this has dropped from the technology point of view. And we're also seeing the prescient risks coming of the environmental threat and the damage to the barriers and the challenges we're going to face. And I think the balance is changing there. So it will take time, but the sooner we can get to it, the better, as far as I'm concerned.
Oh, down here,
Awesome.
Laura down here. Oh, listen.
I was just wanting to ask, if, say, people went for this idea and then it started, then how long would it be? Like once it started and then when it was finished? I mean, how long would it be? And I probably wasn't paying attention, so I maybe don't need to ask this question, but would there be periods of time when there was not, while it was all being done,
Right.
however long it took, and would there be a period of time or periods of time when you couldn't use the barrier or the bridge, the blah,
Yeah.
everything?
Okay, so construction on something like this would probably take 18 months to 2 years, I would have thought, that sort of scale, because you probably have to work through 2 summer seasons. But if you look at this is the aerial photograph of Barrier 2, and the only point of contact between the new and the old is here. So you could build all the yellow stuff completely in isolation before you had to come onto the barrier. The alternative is you could actually continue that structure all the way down, and in which case it would be built entirely in parallel. So there wouldn't be any intrusion in what's going on. The minor bit of roadworks at the top end is the sort of thing you do routinely in civil engineering, where you tie an old road into a new one, and there's a few days of faffing about. But yeah, it is. Honestly, it's that sort of scale. That's what I used to do back in the day, building new roads. So I don't think I think it's really important we don't go, I'm sorry, Barry, you're off for 2 years and we'll get back to you later. So no, that just wouldn't be socially acceptable. And in the case of Barrier 1, if we do that one, basically you'd build the whole thing parallel to the existing barrier. So there'd be no intersection between the existing barrier. You basically come from the car park where just on the north end of Barrier 1, there's a little you'd sort of come from there. So you wouldn't need to get in the way at all.
Up there, yeah. So,
If we can get Swain to do a complete circuit, that'd be good.
I'm a bit all or nothing about it, I think. I'm kind of like, sounds like a great idea, but part of the issue, I suppose, is speaking about sea level rises.
Yeah.
Is it going to have to spend millions, billions raising the levels of Barrier 3 and 4 in any case at some point? And likewise with Barrier 2, if you're building a bridge that's going to connect to the barrier, that barrier has to rise to the level of the bridge in any case.
Yep.
So why not just get rid of them?
Yeah, well, you could be right. Yeah, I mean, you're absolutely right. I was focusing very much on the tidal side of things, but for a complete sea level insulation point of view, taking that yellow line, taking the bend out of that yellow line and taking it down would make more sense, but it would not be revenue generating, that bit, and that's the piece I'd worry about. Because, however, it's really interesting. One of the reasons that some of these schemes don't progress is that they're treated differently from accountancy reasons. So things like roads, as I understand it, are basically written off from an accountancy point of view over certain periods, but flood defences are written off over a different period. And so one of the challenges is going to be trying to make the finances stack up and get the various people together to recognise it's important. Because to be perfectly honest, Scotland hasn't really had to deal with much in the way of sea level rise yet. And it really could have to. As I understand it, the land has been rebounding as a result of, after the last ice age was still going up, and the sea level is coming up as well. The sea level is starting to come up faster than the land is coming up. So we are going to have challenges in our normal environment from rising sea levels. But at the moment, we really haven't had to cost this in. I think when we do start to cost this in, people are going to go, bloody hell, this is expensive. Yeah, but it's not as expensive as not doing it. And I suspect that the monies will have to be made available to future-proof our infrastructure as a whole, and this could be a piece of that future-proofing.
Yes, and there's one up behind. There's Margaret up behind as well.
I would suggest this probably makes quite a lot of sense because there's no option to do nothing, and this barrier thing has been battered back and forth here for about the last 20 years. There's been token gestures made about how they might alleviate the situation, but I think it's going to come and bite us on the behind sooner or later. And I mean, the last 2 or 3 winters there's been several occasions when it's been possible to get stuff shipped across the Firth, but it's not been able to get off South Ronaldsay onto the mainland Orkney, sometimes for a number of hours, and that causes an inconvenience and other problems, plus the fact that you've got situations people need to get to Kirkwall to the hospital sometimes on occasions, and it's just worthwhile really looking a bit harder at this, in my opinion. We seem to be prepared to commit a big amount, or almost prepared to commit a very big amount of money on a speculative harbour development, which some of us who are in the marine field would maybe have a wee bit of doubt about the value of that, whereas this could be an income generator for us, and like Mr. Kermode has said, if they're willing now, after a lot of years, to accept investment in wind farms, and probably Orkney's maybe been a bit late in coming forward with that, for this possible opportunity, we should maybe try and go forward. I mean, there's a lot of technology in this county proven in the field of renewable stuff now, and I think it's done a lot of good for the place, produced a lot of jobs and such, like young people going away to colleges and universities in the past that you would never have seen have now got good jobs here, families growing up and such like, and we should try and take ourselves forward using this sort of thing, in my opinion. Thank you.
Thanks,
Yes, Wayne, I think Margaret, were you wanting that? Oh, John.
Yes, thank you. As a North Isles person, I was very interested in your slide on the correlation between good transport links into Kirkwall and depopulation. We can see that the North Isles, from your slide, are suffering from severe depopulation, and their main transport links into Kirkwall is an ageing and completely clapped out bunch of ferries. And I mean, that's also something that really needs to be addressed.
I completely agree with you, Margaret. Completely agree with you. Yeah, so I was trying to find the slide. It's not going to work. Yeah. Could I pose a question back to you? Sorry, it's going to be because one of the other pieces that's been, we go to Edie on a regular basis, obviously, with what we're doing with the tidal turbines. And I have heard it said that people wouldn't necessarily want a better connection to the islands because of the fact it then makes it more of a dormitory of Kirkwall. And the argument's been made that, say, Shappensea is a bit more of a dormitory of Kirkwall, and people leave Shappensea to come and work and don't work on the island. Not having lived on Edie, I struggle with that view a little bit, because I would have thought the ability to move backwards and forwards and the freedom to choose is actually quite important. I'm putting you on the spot. Any thoughts about, you said as a Northern Islander, you would find it more useful to be able to travel more easily, because that's what I would have thought, but I've had the opposite put to me.
Well, I think it gives the choice. About getting in and out. I mean, the last when I lived in Sandy, I left in 1984, and it took me about 3 hours to get from Kirkwall to Sandy, say 2 hours. I went to Edie about 3 years ago, and because of the boat situation, I left Edie at about 4 o'clock in the afternoon. I had to go to Sandy. I had to drive my car off the boat at Sandy, let them get off, I drove back on, and then I had to go Stronsey, Kirkwall. That's what the North Isles people are having to deal with, because the boat keeps on breaking down and nothing is being done about replacing the ferries. So, you know, it's just something else that's being left, and I think, you know, people need to be aware of that. And if you're an older person or you're not very mobile, you've got a straight ladder to climb up to get up to the lounge. That's what's there. It really is.
Completely agree with you.
Yes.
John down the front.
Yeah, we know that barrier number 2 problems are getting worse because as a good lot of years ago now, I mean, I taught chemistry and physics most of my life. I mean, we know that the waves are getting closer to the shore and the sand's going to keep coming in and the waves are going to keep coming in farther. So the closures, they're going to be, and also more storms. I mean, there's going to be more days when it's going to be particularly difficult. But there are one or two other things to consider. If the project, as you described it, were to be done, you could have marine turbines there, but you could also argue that it would improve the quality of water inside Scapa Flow itself, which in turn would increase the kind of crabs, lobsters, fish, and whatever as well. When you've got moving water, that's better than water not moving. And once you're generating revenue, of course, you could pay for new ferries going to North Isles.
And the longer you wait to do it, the more it'll cost.
Yeah, that's the case, definitely. The interesting point there about water quality, you're absolutely right there, John. It is, the flow is in reasonable condition, but there are certainly some spots where there's little flow. And that was the thing we noticed when we did that survey on the seabed, you know, the fact that there's a lot of silt, and then it was quite a gritty and shelly bottom below that. And obviously the conditions in the flow have changed. And in part, I would argue that's due to the reduction of flushing that goes on as a result of the barriers in. We also looked at other things like, would there be sea level surge, and you know, would it cause a problem elsewhere? You would end up with some very slightly increased wave effects in Ham, because obviously the waves would come through the barrier and then diffract within the flow. But they look like very small scale issues compared with what we're getting on the barriers at the moment. But it's trying to quantify and ascribe value to an improvement in water quality, improvement of access to you know, being able to get your freight in and out, an improvement to the ferry transport. It's bringing together all these points and then the energy on top of it. You go, what does that cost? And what does the bridge cost? Yeah, okay, we're on. And that's the piece we've got to do. We've got to bring all these pieces together.
Right, I think that's maybe it. So we'll let you finish, but sorry, I think we've got.
So we're streaming it, so just to
Got
capture
to
the
wait for the microphone for the people online. Later online. It's not going to do it at the moment.
So in terms of like costing things out, has anyone made approaches to renewable companies?
It's working, Swain. Sorry.
To renewable companies to see if anyone's actually interested in maybe forming a syndicate of some sort, or how far's the project gone?
No, okay, so it's not gone very far, because it sort of stalled somewhat some years ago when I got this job, but it keeps coming back now and again. We haven't really pushed this very much with the technology suppliers right at the moment, because partly we're caught in this odd place with the lack of grid. So if we made this work, we wouldn't be able to put the energy anywhere. But I do think there's going to be other things coming down the track which are going to resolve this in terms of hydrogen and other things. So I think there's going to be a need for greater energy demand in the island, which therefore means the grid problem will, at this sort of scale, will probably evaporate. So there's a timing-based thing here. We haven't pushed it on. What I worry about is if you go back to that diagram from JBA Associates, which basically said, pile a load of rock in it, it'll be fine. The danger there is that you then later decide you want to do tidal energy, you've got to take all that rock away as well. You know, so it just makes it worse. And so I think what I worry about is if we get to a point where there's a lot of political pressure to do something because of the wave overtopping issue, they go, oh, just bury it, it'll be fine. You know, and that's the risk that I worry about most of all. Things like, say, that caisson that was sunk out off Barrier 2. Somebody said, you know, you need a fence to stop the waves, so why just put one fencing stab in? You know, it was just a sort of thing out in the bay. It's not really done anything. It'll just and it's another bloody thing you've got to go and remove. And I hope we don't just get into a stage of just piling scrap in there just to sort of try and stop it. So that's the risk I see at the moment. But similarly, I think we see that there is the potential as an opportunity. As I said, we now know that there is energy. We know the technology works. We know we've got the site. We know we have to deal with the barriers. It's kind of stacking up. It's kind of getting there. It feels as though it's going to be the unresistible force, but we just got to get there. And the sooner we get there, the cheaper it is.
Right, I think that's it then. So the like Neil mentioned that there is, so I hope you'll all be coming aware, an exhibition in the St Nicholas Kirk in Ham of photographs of the building of the barriers that was just opened today. So it's from 10 o'clock every day. You can go along to the St Nicholas Kirk in Ham and see some fascinating photos of the building of the barriers. But so I'd like to thank Neil very much for that talk, and a lot of food for thought, and certainly I have a lot more to tell the tourists about. And thank you, Moya, for organising this.
Yes.
Absolutely fascinating pair of talks. And thank you, and good night.
Ciao.